Hello and welcome to Alt.NET September. And we had Aaron with us 1 second ago and he's just left. So he should hopefully be back with us shortly. And I'll add him back into the stream. Here we go. Here we go, Aaron. That was a dramatic entrance.
Yeah, that was just wrong button. Don't mind me.
Oh, good. You're not going to disappear on us again, are you? You're all set. Just stay around.
Fingers crossed I won't. Yeah.
Well, welcome everyone. So please say hello in the chat, and so we know we're not just talking to each other, which is fun, but even better if we've got an audience. Have we got old co-organizer Richard there, perhaps? As well. Hey, Raymond.
It's a good start. I was like, oh, I can post comments, and then I realized I can't because I don't have a destination set within inside of StreamYard. I'm not sure what that means, but yeah.
Yeah, it's easiest to do in Twitch, I think, if you've got another device.
Yeah. All good. Well.
All good. All right. Well, sorry, go for it.
We're here to talk about something, I'm sure.
We are. So, as usual, we'll have the prizes later. So please stick around to the end if you want to get a JetSbrains license. And besides that, more excitingly, we have Aaron, a long-time friend and presenter of the Alt.NET group. I don't know, how many times have you presented, Aaron? Must be over the years.
I don't know, dozen or so at least, I reckon, over the last 10, 12 years.
Yeah, I think you must have been one of the earliest presenters and one of our most frequent, definitely, and one of the most popular, of course. Most charming and handsome as well.
Oh, just keep talking me up there, James. It's lovely.
Yeah. Just a little bit to live up to there, but I have every confidence. So Aaron's going to tell us all about how you can do generative AI in .NET, and you don't have to use Python or Ruby or some other environment, and you can do it all more beautifully, I'm sure, in .NET and make amazing things. That's right.
Yes, exactly.
And it will be hands-on too. I think we should see some demos and some code. So yeah, as usual, if you've got any questions, then stick them in the chat and I'll surface them and interrupt Aaron at reasonably soon after you post it, but not right the second, right in the middle of his word.
Yeah. Hey, you can, but it doesn't mean I'm going to answer it. You can ask the question whenever. It's whether or not I answer it. That's the different thing.
All right. Well, let's get rolling because Aaron's got a lot of content to. The full hour and maybe a little bit more is the feeling I'm getting. So hopefully you can stick around for all of it, and the prizes will be at the end as an incentive to make sure you stay every last second. So,
yeah, exactly.
I'll bring up Aaron's presentation. Here we go. And I'll put him at the top. Okay. Never mind me, I'm at the bottom. This is good. All right, to you, Aaron.
All right, well, as James said, we're going to be talking about generative AI, but from the perspective of a .NET developer, because that's what I am at heart, and I want to make sure people realize that you don't have to be jumping into Python or some other language if you want to try and build with this new style of AI applications. But yes, introduce myself. I've been around Alt.NET for quite a while now, but I work for Microsoft and I'm in the cloud advocacy team. My area of focus is .NET, hence why I'm doing a talk about generative AI and .NET. But yeah, I've been doing web dev and .NET development for close to 20 years now. You'll find my social media and email and all that kind of stuff on screen now. If you do want to ask a question that I don't feel like asking it on stream, or you come up with something after the session, you want to reach out, feel free to ping me on a variety of social medias or on email and things like that. But let's get into the talk. And honestly, let's just start with a demo. How many talks have you seen where you just spend the first half of it is just slides. Let's not do it that way. We're going to just jump straight into a demo. So let me find my demo application here. So I've got a application that is written in .NET. You see there is a .NET code base there. And we are going to just run our OpenAI. Oh, look, one of my kids has come to join us. Go, yes, lovely, buddy. You go get your pajamas on.
Pineapple pocket.
You do have pineapple pockets. All right. Off you toddle.
Yeah, what if the codes compile like this?
Yeah, while the code's compiling in the background, we'll be entertained by my 5-year-old wandering in. He's just got some new pajama pants. All right. So here is our application, and we'll see at the bottom that it's popped up as a terminal application, and you can see I was testing it earlier today to make sure that it does work. And it started off, it said, well, hi, I'm .NET Bot and I'm here to help. So let's ask it a question. When was .NET released? Let's zoom that in a touch more. Whoops. Okay, so .NET was initially released in February 2002, but it's undergone a bunch of versions. It says with the latest stable release being .NET 5 from 2020. So I mean, here you can kind of see that, like, we're obviously working with a model that is a little bit outdated because .NET 8 is coming out later in this year. .NET 7 was last year. So there's been a few releases since then, but you can see that I was able to ask it a question. It was able to then give me a completion response to the question that I had there. So like that's the kind of thing that we can do with these AIs. And no doubt you've seen these things and played around with them and stuff like that. And so is the question saying like 2000? Yeah. So I think some of the initial previews were around about 2000, but first stable release was then. We can keep asking it questions and keep interacting with it, but for now we're going to jump back to the slides to kind of talk about, we'll set a bit of a scene as to how we got to the point where we're building this kind of an application. So we'll say goodbye for now, and we're going to close that terminal down. Okay, so that's the basics of how an AI works. Like we provide it with a prompt, we converse with it, it gives us a response back, so on and so forth. Now, onto the topic of AI. And look, the first thing that I get asked when, can you give us a talk about AI? It's that, can't AI just do it for, like, AI is going to take your job? Like we've all seen the joke, we've all seen the memes and stuff like that. It's like, yeah, yes. And when I was putting this talk together and I was talking about it with one of my colleagues, they've just gone, isn't AI just writing the talk for you? I was like, ha 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 ha. And yes, you're feeling like Bart Simpson in that moment. But well, before we talk about generative AI, I kind of want to talk about what were the precursors to getting to generative AI. And one of the things that kind of make all this up, fundamentally it starts with a model. Now, we're going to see a bunch of different ways that we can use generative AI in this application. And one example of how you can use generative AI is to generate images. Now, throughout the talk, I've got a bunch of images, some of which have been generated with a generative AI, and some of which are stock images from stock image websites. But fundamentally, the model is the thing that underpins all of this. And, well, you can kind of think of the model like the brain. I guess that's kind of like a humanization analogy that you've got. It's the thing that we've fed data into, and it's kind of we've taught it how to interpret that data to then extrapolate results out of it. So the more data that you feed into your model, the more intelligent it can become, or at least seemingly intelligent. We'll talk a bit more about intelligence later on. So if we've got this model, which is just like this brain or a database or something like that, well, what can we do with it? Well, AIs, I mean, this isn't anything new. Right? We've had AIs in a variety of different forms for a lot of time. We've seen depictions of them in media, like from as far back as like the 1950s. obviously, HAL 9000 is a classic example of a conversational AI. Like, it's something you can talk to. Now we have those today. They're in our pockets. They're on our wrists. They're around our houses. Whether it's your Alexas, your Google Homes, your Siris, or whatever the case may be. Like, these things exist, and they're just part of our lives. We deal with AIs all the time. But this is a form of AI where we're doing it's not maybe AI as we're going to be talking about in terms of generative AI, but it's a different form of this where it's called where we leverage a technique called natural language processing. So we take the spoken words, we interpret those to convert those to text, because the computers deal with text, and then we try to understand things about what has been asked. What are the topics or key phrases that are in there? What's the sentiment of that, to work out, because just raw text doesn't have that in it. So we rely on processing the language and the inflections in language and the nuances in the way spoken words are provided to infer other bits of information around that to enrich it. A good example of the way spoken language can influence a sentence and the interpretation of a sentence is, take the sentence, "I never said they took my money." Now, you can emphasize each word in that sentence. So it's a 7-word sentence, and you can emphasize each word different. When you emphasize each word differently, you change the intent of that sentence. I never said they took my money. I never said they took my money. I never said they took my money, and so on and so forth. So this is where natural language processing comes in, and it can understand the where was the emphasis, and use that to interpret things and provide more quote unquote intelligence down the line. And then we've got image classification. Image classification is another really common example of AI that we've used. And we've been using it for a long time to try and detect things inside of images. And the way that we do this is we provide it with a bunch of training data. So we might have a model that is already understanding the concept of what a dog is. So we then provide it with a bunch of images of chihuahuas. And then we provide it with a bunch of other images and ask it, is that a chihuahua? And it's going to use the way that we've, it's essentially it's reference data to determine whether or not something is a chihuahua or a muffin in this case. And I can tell you, like, even just looking at this, giving it like a quick cursory glance, there's a few in there that is a human. I struggle a little bit with. But I mean, this is how we do things like facial recognition. We have these machine learning models and that understand the structures of a human face, eyes, nose, mouth, ears, etc., and then we layer on specific photos of yourself. That's how, like, on your phone when you do face unlock, whether it's like an iPhone or an Android or whatever the case may be, or Windows Hello, which I've got here on my computer. That's kind of how that works at the base level. Now, there are a bunch of other styles of AI that, like I said, that we've had around for a long time. Things like Azure Cognitive Services is something that we've had at Microsoft for years that can tackle these sorts of problems. But this brings us on to generative AI, and really the topic of today and the topic of now when it comes to talking about AI. So what makes a generative AI different to any of these other AIs that we've had in the past? Well, it's the scale of the models that we're working with. We're working with what we call large language models, or LLMs. So an LLM is it's basically the latest evolution in the way we build models, where we were talking about models in the past of having hundreds of thousands of data points with inside of them that they can do inference and do decision making out of. Now we're talking about millions, potentially even billions in things like we're not exactly sure how much is in things like GPT-4, GPT-3.5 and stuff like that, but it's theorized that there's like billions of data points that they've got with inside of them to be able to do inference out of and give us the kinds of results that we're seeing. But in this scope of generative AI, we have a whole bunch of sub-components that make up how we work with these systems. Another one I want to talk about is prompt engineering. Because, well, at the end of the day, a LLM is, well, and again, to kind of humanize it, it's a brain. It's not doing anything until it's provided with input. And that input comes in the form of text. So we give it text, and then it's going to complete that text and give us a response back from that. So this is so it's a completion engine, and in doing so, well, we have to really think about the thing that we're giving it to get said completion. And this is where the concept of prompt engineering has come from. That there's almost a I dare say art form in the way that you craft up the input that you're giving to your LLM to then get the completion back from it. The demo that we saw, while I might have typed in, when was .NET released, there's actually a whole bunch of stuff that's happening behind the scenes of that will give us that helped it craft that response that I've provided from like a prompt engineering standpoint. And prompt engineering is it's more than just like how do I massage the sentence that someone has written to get a response, but there's other things like zero-shot learning and one-shot learning and few-shot learning, where you can give the LLM as part of the prompt some more instructions around how you want it to structure a response back for you. Or how do you make it give you back a code response versus just a plain text response? And the approach of doing that is the result of this prompt engineering discipline that is spun up inside of technology. Now, we've seen unprecedented growth in the adoption of LLMs, and in particular, like one in particular. I'm sure that everyone here is familiar with Chat GPT. Most likely everyone has used it at least once to experiment and see how it works. But if we think about how fast this has grown in industry, you can see on the graph like the time to 100 million users, and other equally disruptive, or if not more disruptive, technologies that have happened. Things like mobile phones, the invention and the consumerization of the internet. Like the internet took 7 years to get 100 million users. ChatGPT did that in 2 months. Like there's no denying that has been an explosive impact in the way that we think about generative AI. So let's talk a bit more about ChatGPT specifically in the concept of generative AI. Now, it's important to understand that ChatGPT is an application. It is not an LLM itself. ChatGPT is a web UI with a text box that makes REST calls. And that's actually all it does. It isn't a model. It doesn't have intelligence in it. It is just making HTTP calls, it's posting some data, it's getting some data back, and it's displaying it in a UI. It's building strings. But what it's using is it's using a GPT LLM under the hood, or a generative pre-trained transformer model under the hood. And OpenAI, who is the company that produced ChatGPT, have actually produced a whole bunch of different LLMs that we can use. Things like GPT-3.5, GPT-3.5 Turbo, which is a slightly smaller version of GPT-3.5 and arguably faster as a result of that. GPT-4, DALL-E 2 and DALL-E 3. If you're watching the tech news this past week, DALL-E 3 has just been released, which is doing image generation and a bunch of other things like that. But what ChatGPT does is it brings the conversational experience to that LLM. Because like I said, it's not doing anything until you give it data or you give it a prompt, and then it will give you a response back. Another example of an LLM, or sorry, of a generative AI with an LLM experience is GitHub CoPilot. So my little GitHub CoPilot is always over my shoulder here. So GitHub CoPilot is using GPT models under the hood. It's I think it's GPT 3.5 at the moment. Or maybe it's 3.5 Turbo. I'm not exactly sure. I know it's in the 3.5 suite of models from OpenAI. But what they've done is they've tuned it very specifically to work with code and give you code responses, and only responses related to tech. Like you can go and ask it, what is the most recent Star Wars movie? And it won't give you a response for that because that's not code related. And the way that they've done that is they've put some very strict boundaries around the prompts that go in, and the prompt templates that they build up are very tightly controlled to only give you code responses or code adjacent responses. Like you get it to obviously explain code, and that's not going to give you just back some raw C# code, but it will give you back a code response. And GitHub Copilot is actually really kind of fascinating when you start playing around with it and understanding more about how it works, because the way that you can get inferences back or completions back from an LLM is you give it context. So I can give it like a line of code, and it can look at the line of code that I'm on, and it can give me maybe a completion of that line of code. But what GitHub Copilot does is it actually looks at more than just the line of code that you're in, or even just the code file you're in. It looks at all the files you've got open in your editor and adds them as context to the requests that are going out. So where like you could use Chat GPT to generate you code, and that works just fine, it isn't contextually aware of your program, of the application you're working within. So it doesn't understand your types. It doesn't understand your methods. Whereas GitHub Copilot, as opposed to Chat GPT, does that because it's looking at your code base and it can add additional information in there. It's kind of interesting. Like I said, once you start understanding the nuances of the way that works, it really changes it. All right, so this comes to the fundamental question of like, are these systems intelligent? And there's obviously a huge philosophical discussion we can have about intelligence and AI, and like, are we on the cusp of like a proper thinking machines and stuff like that? But for me, it's really important to remember that just because it can predict what you should be able to get back, or like what is the completion that is going to make the most sense for this statement that you're working on, that doesn't mean it's intelligent. Like a parrot can complete a sentence if you've given it like enough training on it, but does that mean that it is inherently intelligent? Okay, it comes down to the philosophical question of what is intelligence, and I think that's kind of beyond the scope of what we want to do at an alt.NET presentation. But it can seem very realistic. Like if you've played with Chat GPT or any of like the other comparable tools, like it can seem like you're almost working with a human. Like the responses can seem very human in the way that it converses. It can seem somewhat intelligent. But ultimately, all it's done is it's picked what it has been trained to understand is the right completion or the right outcome to what you've given it. And well, right is obviously a matter of interpretation, and it's just the way that the model is trained that we perceive what it's giving us back as right. But it isn't always going to give us back something that we can perceive as right. And this is where we start seeing, or the concept of hallucinations comes into working with LLMs. So if you've played with ChatGPT or Bing Chat or any of that kind of stuff, and you've given it something, and like every now and then it will give you a response, and you're just like, I know that that's wrong. Like whether it's something and it's got numerical values in it, and you're like, I know that that's wrong. But how did it do that? Like, why did it give me a response that is just so far out there and belongs on like some obscure social media platform that is peddling conspiracy theories instead of in a mainstream system that we're using to write blog posts these days? The concept of a hallucination comes because, well, it doesn't actually know the answer. Like your LLM doesn't know the answer. It knows answers. It doesn't know the right answer. So it's just going to make something up. And there's ways that we can tune that. When we go back into the code, we'll have a play around with some of this stuff. But there's things like temperature, what level of creativity are we allowing the LLM in the response that it gives us back? And we control that with the temperature of the response. And if we make it too random, or like give it like too much flexibility, it can give some really crazy out there things that they kind of look like words, but they're very much not words. Now, I would be remiss about talking about generative AI and OpenAI in particular, and not talking about the fact that we do have an OpenAI service as part of Azure. And well, you might be wondering, what is this? Because to make it clear, OpenAI is an external company. Like that's not a Microsoft subsidiary or anything like that. OpenAI's goal is just to make the best like LMs and general artificial intelligences that they can. And we want to make sure that you as an application developer can build the kinds of applications, leverage the sorts of tools that you want. So we've entered in a partnership with OpenAI. So we're helping them build out infrastructure and systems, and they're helping us by giving us access to the GPT models that that they've produced. So the idea is that what we've done is we've produced the Azure OpenAI services, which is pretty much what you get out of OpenAI, but we've added a few layers over the top of that to make it a bit more tunable, particularly with your own data. I see that there was a question about is OpenAI really open, and the answer is no. OpenAI isn't open source, or and they haven't published like their models as something that you can download and like run on your own beefy computer if you like had enough GPU power that you could try it or anything like that. No, they aren't models that just anyone can access. So they're like, OpenAI is a paid service. They have a free tier, and same with Azure OpenAI services. It is a paid service. But the idea of like an LLM is, it's not the kind of thing that you're necessarily going to run yourself. There are plenty of open source approaches. Little Llama, I think it is from Meta, and a bunch of others. I've seen some diagrams. There's like a dozen or so different LLMs out there that you can use, and they're all going to be tuned slightly differently. So with Azure OpenAI services, you can get access to a bunch of different models, things like GPT 3.5, 3.5 Turbo, GPT 4, DALL-E 2. We'll be bringing DALL-E 3 when that's available to us as an option. Codex for doing code generation, which is what was the original underpinnings of GitHub CoPilot. Like I said, they're now using GPT 3.5 Turbo, and a few other models along the side of this. So what makes Azure OpenAI service different to OpenAI? Like, if it's a paid service, why would you go with Azure rather than just go straight to the source? Like, it seems like I cut out the intermediary organization in that. Well, fundamentally, we want to make sure that this integrates as well as we can with inside of any other applications you've got deployed to the cloud. And something that is like a big mantra for us is that Microsoft runs on trust. Like if you're deploying to Azure, like you're trusting us to hold your data, and we want to extend that same level of trust to the way that you build AI systems. Because at the end of the day, the data that you have in your organization, whether it is like data about your customers that you're storing in a SQL database, it is Word documents that have been created from your sales process, whether it's your internal HR documents around policies and leave and things like that, that's your data. We want to make sure that if you are wanting to use that within inside of an AI-enabled application, that it is treated as securely as it is for any other system that you would be building. We want to also instill that any data that you use in conjunction with Azure OpenAI service is not used to train any of the AI models that are used. Like the AI models, you buy it off the shelf and you've just got that model, and then you put a layer over the top of that, which is your own data that you use, and that adds some additional context around it. And we want to make sure that you've got the kind of security and privacy controls that you would have in any other application you're building applied to the way they're building AI. This is a new approach to building applications. There is a whole bunch of fascinating security problems you can have. And I think when Bing Chat was first publicly launched, like the initial preview of that, there was some really fascinating tech articles that were written of people that were working out how to, using the prompts that were available, exploit the system, break out of the sandbox that it was running in, and pull information that was actual training data that they used for Bing Chat. We want to make sure that we give you the tools and the systems in place to make sure that you don't have that. You don't end up, or you also don't end up with a chatbot that becomes abusive or violates other codes of conduct that you have within inside of an organization. All right, so let's talk about .NET, because really that's what we're here to do. Let's talk about how this all comes together from the perspective of .NET. And well, we have a .NET SDK, and the .NET SDK that I'm going to be using in the demos when I jump back there. Like we produced that, so it's a NuGet package Azure.ai.sdk. Is it Azure.openai.sdk? I will check that. It's in my notes elsewhere. But that SDK is applicable for Azure OpenAI services or OpenAI. So you can swap between the two. And literally all you do is you change the connection information you provide to the OpenAI client, and everything after that is the same, because Azure OpenAI service exposes the same API surface area as OpenAI do themselves. Because like fundamentally, it's just a wrapper. Like it's just a wrapper around REST endpoints, and giving data structures that provide access to that. But before we jump into the code, there are two final topics to understand with the way that we work with AI systems. And those are embeddings and completions. Embeddings are the way that you take a string of text and turn it into a series of numbers. And then from those numbers, you can compare them to other bits of text and find similarities. So let's say that you've got someone that's provided a phrase to your as part of your prompt, and you want to find things that are related to that. Well, there's no, like, you can't look at the words themselves and do direct relationships. Instead, we generate embeddings from that text, and then, yes, as someone has astutely pointed out in the chat, we then use a vector database to compare embeddings that we might generate from a prompt to previous embeddings that we've got. And then we look at similarities, because numerical similarities are a lot easier to interpret than textual similarities. And I've got an example of how we can do similarity detection and how we can use a vector database to do similarities in an AI-centric application. If anyone's interested, the mathematical operation that it performs is called a cosine similarity check, which has a equation that is not overly complex, but complex enough. Thankfully, it's the kind of thing that GitHub CoPilot generates for you if you don't want to write it yourself or you don't want to go find a NuGet package. But we can also generate. We can use OpenAI to generate embeddings from our text. So you might do that initially to pre-train your data, generate embeddings against your initial data set, and then store those in a vector database, like whether it could be cognitive search, it could be Redis, it could be something like Porcupine, or whatever the case may be. And then you just do a comparison that, essentially a SQL query, but with mathematical operations instead. And then we've got completions. So the completions are the primary interface that we use with getting responses back from our LLM, and particularly OpenAI LLMs. So we'll give it a text, we'll ask for a chat completion, and what it's going to do is it's going to attempt to finish the sentence that's been provided as part of the prompt. And this is where prompt engineering sits around that. We can add some context to that. We can add structure to the way we want it to give us our completion, but fundamentally it's going to try and complete the sentence. So if we were to give it, request a completion for to be or not to be, it would likely complete with "that is the question." I think that's the correct Shakespeare quote, at least the start of that Shakespeare quote. But that's because it's been trained to work out what a completion looks like, what sentences look like, what words are likely to come next. It will weight those words and then against what it's been trained on, and then give you a completion. Think about this, like, it's really, really advanced, like auto prediction in your phone's keyboard. So let's talk. Actually, let's jump over to a demo. I was going to talk about another tool, but we'll come back to that other tool. Instead, we're going to jump back into our demo, and here it is here. So actually, let's start a from scratch demo. We're going to create a new notebook here. We're going to do this. As much as I would love to do it in F#, I know that the audience is more likely to be wanting to do C#, so I will stick with C#. So what I don't need GitHub CoPilot at the moment. So I'm going to use a Polyglot notebook. So this is an extension for VS Code. It's kind of extended from the idea of Jupyter notebooks, but we can use it to run a whole bunch of different languages, in this case, C#. So what we're going to do is we're going to start off by importing the NuGet package of azure.ai.openai. Oops, I can spell OpenAI. And we're going to import, currently this is a preview package, so I just have to import it as a preview package. All right, so let's run that. Let's just download a NuGet package. Excellent. So that's there. And then we're going to add some more code. We're going to need to get some stuff from, sorry, CoPilot, I don't need you just a moment. I'm going to need to get some information, like some connection information to connect to OpenAI. So we're going to use the Microsoft.NET Interactive. So we're going to use that, and we're going to get a string endpoint, and we'll await kernel dot get user input, and we'll say enter the endpoint. I get the key, but we're actually going to do that as a protected, no, was it secure string? I think it's secure string. And we will get password, mostly because I don't need to see, no, it's not. What is it? It is, what is it? Not secure string. It is a password string, password. I've started doing, I've started to move away from using var in the way that I write my code. And I much prefer it. I much prefer not using var now. Okay, last one is going to be, we're going to get the model. So this is going to be, which model are we using with the inside of our LLM? And then we are going to run this. Okay, so let's grab the HTTP endpoint. So this is the endpoint of an Azure OpenAI instance that I have previously provisioned. That is my access key, and then we'll use a model that I've previously deployed. All right, cool. So now we are going to say, using the Azure AI.OpenAI namespace, we are going to create a OpenAI client, call that client. Now we need to provide it with an endpoint, which will be a new URI of the endpoint. And then we are going to provide it with new Azure key credentials, and value, it is get clear text password. All right. Now, do I have enough closing parentheses? I think so. Yep. Actually, let's break that over multiple lines so I can see this a bit better. It's a little bit more zoomed in than I would normally have my editor, but there we go. Okay, so clear text password. Whoops. Clear text password. We'll close those parentheses. Close the key credentials. Yep. And oh, whoops. Yeah, I can ignore that red squiggly. Okay, so let's run that code. Make sure I got that correct. Okay, cool. So now we've got our OpenAI client. And the next thing I'm going to do is let's execute a completion. So we're going to say, using Azure, we are going to create some chat completion options. Options equals new. And we are going to provide this with that. And we will provide it with some messages. So messages are our prompts. So this is going to be a new list of new chat message. And the chat message has a role. So who is the person, or who is the role of this message that's coming in? So that's coming from the user. And when did alt.net Sydney start? And then we're going to complete that. So that's closed there. We will close the squiggly. We will close the round. And I think that is all of them. let's see, new, and then we have close squiggly, close round. Okay, that's right. Okay, so we've completed. So that's our. So that's the things that we're going to give across to OpenAI. That's not what we get back. We get back a response of chat completions, and it is. So this is where GitHub CoPilot is attempting to complete my code for me, but it doesn't quite know what to do. So it's giving me incorrect stuff. There we go. That's fine. That's why it's a CoPilot. You're still in control. So we'll go in and we'll modify things as we need. So we go. We generated the chat completions. Cool. We've given it a model, and we will do a for each chat choice in, there we go, and we will console.log the message content. All right, now let's run that.
Dimitri's wondering your dislike of VAR these days. Do you want to go into it a bit more?
The reason I've stopped using VAR is I just, well, first off, I can do new, and I don't have to type out the type inference there. The other reason is that I'm finding it easier to look at code when it's explicitly typed and not have to, I guess, try and understand so much from the right-hand side of the assignment operator. Oftentimes you would have this out in a separate method call or whatever, and you're relying on the method call being well written and stuff like that. Particularly then when you start working with async, it's like, is this async or is this not async? I also find it more useful from a refactoring standpoint. As I refactor stuff, it's you don't kind of have these hidden points where you don't realize that the type has changed until much further down your code base because you've assigned it to a var. The var is fine, and you scroll down and all of a sudden, oh no, I've tried to use it and I've expected a property that doesn't exist. I just find it a lot more explicit like this. Yeah, and I also spent a lot of time earlier this year working on a code base that wasn't using var at all, and it was, I found it almost refreshing. I've come back to .NET after a number of years working particularly in JavaScript. So coming to a language which is obviously strongly typed as opposed to JavaScript, and being able to really leverage the strongly typed and not have to constantly try and figure it out myself. I think that's more, and also I'm getting older. I don't have to think as much. Okay, so our completion ran, and unfortunately, it doesn't know about alt.net. It doesn't know when alt.net Sydney started. That's a little disappointing. Okay, that's a super simple way that we can implement this. But let's have a look at that application we started with. So I've got my program here. Actually, let's just get it running. Debug. We'll debug it again. Okay. We'll leave it running in the background for the moment. Talk a bit about what's happening. Well, we've got our fairly innocuous setting up of our application, just using some accessing our settings, dependency injection. This is doing a check to see whether it is using the Azure OpenAI service or it's using OpenAI. And you can see there, we're getting an OpenAI client, and just the difference is we provide it with the key, which is your key from OpenAI, or you provide it with the endpoint for your instance of Azure OpenAI service, and then the key to that Azure OpenAI instance there. So, and after that, it just works the same no matter what. The brains of this application lives within inside of this console service. So it's a hosted application, like I said, just so it does dependency injection. And the start async method happens here. So I'm just looking for goodbye being a keyword. If you type that in, it's just going to bail out. We're setting up our chat completion options. We can see here I'm saying I'm doing some things like the maximum number of tokens. So how many characters can I send to my LLM? There is a finite amount that you can send. It's 8,000 and something for GPT 3.5 Turbo. but you might want to restrict that in your application. So you're working with much smaller sets, and obviously the smaller it is, the more constraints you might be placing on top of your LLM. Temperature, so this application, you can control the temperature and a few other things like that. And then we're starting off our messages. We're starting our messages with this system prompt. So if we come to the system prompt, I have defined that in here as you're a friendly assistant named .NET Bot. You prefer Australian English as your language, and you're an expert in .NET runtime, in the .NET runtime, and C# and the F# programming languages. Now, because I've got that, you prefer Australian English. Let's just, out of interest sake, let's go. Should the word color have a U in it? I work with a lot of Americans, so I like having this in there. So yeah, you see, as an assistant, I follow Australian English conventions, which includes using the letter U in words like color. However, it is worth noting that different English speaking regions would have their own variations. In American English, for example, color would not have a U in it. So this is really basic prompt engineering. We've given some context to the way that we're working with our AI, and the way it's providing things to the LM. It's going to do things with Australian English. So if we were asking it for things and it was giving back responses, it would use, and the response like contain the word color or like neighbor and things like that, it would include Australian English structure to it rather than American English. So like I said, this is an example of basic prompt engineering. All right. Another thing another fun one that we can do with prompt engineering. I'm just going to deviate off script, because there's nothing like demos where you deviate off script, is there? I'm just going to make this a multi-line string. Oops. And then we're going to say, let's just break this down over a couple of lines. All right. Expert in .NET. And that respond using Australian colloquialisms and slang. There we go. All right. Debug. And again, let's kick off our application again. This is a fun one. I've put this in a couple of sample applications so far. Again, because I work with a lot of Americans, it's fun to do this kind of stuff. Okay, let's come back into our application. Oops, pop that up to full screen. What is the color of the sky? Just going to ask it something completely random out there. And yeah, here we go. Mate, the color of the sky depends on the time of day. During a clear day, the sky is blah, blah, blah. So like it's used in like an Australianism. It's used the word mate to start that off. So like again, this is how you can give kind of personality to it. But let's move on from Australianisms, and instead let's go generate me a type for person. Actually, no, for author that has a first and last name. All right. So now I'm obviously wanting a coding thing. I mean, you could infer that you're wanting coding because I said generate me a type, and because we told this in the system prompt, we've told this LLM that for per author. Okay, cool. I don't know why it's called per author, but whatever. Because I'd given some context around like this is you're understanding .NET, you understand C# and F#. It's figured out that those are the kinds of things I should do. It should generate me a C# and an F# example. Okay. Thanks. From now on, only respond in C#. C#. All right. Cool. So it'll only do C# responses now. Let's say, can I have a list of 5 authors? Now, I haven't told it what structure that list should look like. But as we can see, it's used that type that I had there before, per author. It knows that first name and last name are the properties that were defined up here as string properties. And it's also only giving me C# responses. It's not giving me F# responses. Okay, well, how would I find a author based on their last name? So let's see how far we can get it to go in terms of code generation. Okay, well, there we go. It has done it's done a basic link statement, right? It's defined a local variable called last name defined. It's used first or default. It's then done a null check and then given us a response out. Sweet. Now do it in F#. And okay, so do what in F#? That's the thing. Okay, there we go. So that's how we can do that exact same chunk of code in F#. Great, and it's giving me a bit of an explanation around things like like what try find is. It's on the list module. We're getting an option per author because we don't do nulls in F#. We do optional types, and then we're using a match expression and so on and so forth. All right, now to really test it out, generate all the code in VB.NET. Let's see how well it can do in that. Like, can it regenerate all of this stuff in VB.NET? It hasn't generated me the class or anything like that, but it has generated me the filter statement. So how was it capable of doing that stuff then? Like, how was it able to remember like per author, the structure of it, the link statement that we did, and all that sort of stuff? Well, the way that has worked is that when we're working with our LLM, this list of messages or this chat history is something that we build up. So every time this application gets a message, every time we do a prompt, we put in a user role message. So this is the input that's come in from me. So that's what I typed into the prompt. And that's added to the chat completion options or the messages there. And then it will attempt to find anything. And if it doesn't, it just says an I'm sorry response. Otherwise, it's going to write out the assistant message, and then it's going to add that chat as an assistant message to our chat history. Let's just pop back in here and we'll let's breakpoint on goodbye. Okay, so let's go goodbye. And now if we were to have a look at our chat completion options here, let's just give us a bit more space by collapsing down some of these things. We'll see we have 15 messages in there. We'll see that we have like this particular message here. If we can expand it out, we'll see that one is the generate all the code in VB, and that was from a user role. And then here is the code back, from that was then done, and that's an assistant role. So, and because that's all there, when we send out the prompt or send the message across to our LLM, it contains all of these chat messages. It can understand what ones I've previously asked and what responses it's previously given, and use that in the way that it builds out our future responses as we ask them. So that's adding more context to it. And that's how it knows certain things. It knows what to give us as a response. Now, before we jump back into the slides and kind of wrap it up, because I know we're getting towards the end of time, I do have one other demo application I want to bring up here. So this is something that I've been building with a colleague of mine. And let's actually make sure that is still running. It is still running. So this is an application that's using embeddings to explore YouTube playlists. So what we've done is we've scraped a YouTube playlist and taken the transcripts of those sessions that were in those YouTube videos. We've then sliced them down into, I think, 3-minute segments with 15% overlap at either end. So you get, so if you've got like sentences that are overlapping between timestamps, like 3-minute timestamps, you get those continuations. We then have generated embeddings off those, which we store in a vector database, which means that I can then converse with this application. So let's just restart this. So the playlist that we're using here is from the AI show on the Microsoft Developer YouTube channel. And I can ask it a question. Let's say, what can I learn about VS Code tools for AI?
Can you zoom in a bit, Aaron?
Oh, yeah. Let's zoom in to 175. Okay. So here we go. And it says, I found a video here in which the speaker discusses Jupyter notebooks in VS Code for Azure Machine Learning. Well, that sounds very much like what I asked. But I said VS Code tools for AI, which I guess it's kind of there, but it's also it's matched on like Visual Studio Code, like it knows the full name there. And I've said AI, but it's Azure Machine Learning. Like the word AI only like appears once in here and things like that. And we'll see that there's some topics that it's identified with inside of this VS Code, Azure Machine Learning. We can have a look at some of the other sessions. So these are the sessions that it's identified that are also possible with inside of this one. We can even have a look at the prompts that were sent out in this. And I was like, just making sure I hadn't forgot to clear out chat history. But you see, you're a system assistant that helps find videos by subject. Write a 60-word summary using a 60-word introduction for the video using the summary below. We then provide it with the summary of the video and the speakers, and then a bit more information. And that's how we can generate this out here. And let's ask it something else. What are vector databases? So we can ask it we can ask another question, and it's going to go out. And you can see that my UI is struggling a little bit with the zoom levels that I've got here. It's not particularly responsive UI, but here we go. It's found. No, it's still got some history in there. This one's a work in progress, so it does have a few issues in it. It's overweighted the previous session information that's in there. But if we have a look in here, we'll see that there is some stuff around these ones more related to the concept of vector databases. Now that's working by, it takes this prompt here. It will then generate embeddings from that. It will then search against the vector database that I have for embeddings that match or at least closely related. And we'll see that we've got this one here was a 75% match to to the topic at hand. And then that will come back with some results. So it seems that we don't have a whole lot of stuff about vector databases, but this is kind of the best that you might get in terms of that. Yeah.
Roman's got a question for you, actually. Yeah.
Yeah.
So if Microsoft changes the name Azure to something else, will it require retraining?
Like as in, like if the service was changed, or I mean, fundamentally yes, because the level of intelligence is only as good as the data that it's been trained on, and if it doesn't understand that that Azure and Aubergine are, let's pretend they got renamed as Aubergine. They were synonymous, or they refer to the same service. It wouldn't understand that. So yes, you would need to retrain your LLM to understand those changes that appear inside of that. So just like very quickly on how this particular application works, let me close off all the 100 tabs that I've got open here. There we go. So this one is it's a .NET server with a React front end. It's not written as a console application this time around. We have a minimal API that we land in here. This is coming in here where just you've got to sign in, so we're just finding the user that's signed in. We get the prompt that's been provided as part of the HTTP request, and then we've got essentially a decision tree, because I can do other things like ask it, find me more sessions. So I can ask it a follow-up question, and how does it how does it know what to do with a follow-up question? Well, find me more sessions on what? Well, here we go. It's finding some more sessions. It's disproportionately weighting towards the concept of VS Code, because that was my initial prompt, and I'm still working on the prompt templates that are provided for this. But here's some additional sessions around VS Code and AI tooling. So how do we know how to do those kinds of decisions? Well, what we're doing with this is we're providing when we're doing our chat completion, we're providing it with some function definitions of how to interpret the prompt, not as necessarily a completion of sentence, but a completion of potential functions to execute. So we're saying that, that this is a description of what this function could do. And then it's going to have things like the subject, and then this is how it can identify is subject a property of this completion. Rows, how many rows do we want? Are we skipping values through? Or are there other things we're doing? Like I can say clear, and that's going to clear out my history. But to do that, oops, history has been cleared, and it didn't reset my UI properly. Because, well, oh, don't want Twitter. I didn't hit the clear button. So how do we know to detect clear or to get more videos? Or if I typed in help, how do I use this AI? This should trigger off a help branch because it's detecting that as like a help request. Oh, no, it doesn't. Live unscripted demos are happening there. I will go back to the person who wrote the functions and let them know that help doesn't work the way that they wanted. But anyway, this is a much more advanced version, the application than I had in that console app. We'll be hopefully releasing this soon. Once we iron out a few of these little bugs that we've got here, and kind of talk a bit more about how you build a system that has this level of complexity, because fundamentally this is the kind of thing that people are going to be doing with AI, or way to integrate AI. It's looking at your own data, not just generative AI as like this general purpose LLM, but how do you use it in conjunction with your own data? In this case, our own data is transcripts. So yeah, we're building on top of that. Just before I wrap up, I want to touch on bad animations in PowerPoint. There's when you start building out more complex applications, you're likely to want to start looking at tools to help you orchestrate the way that you build your AI-centric applications. One of those options out there is Semantic Kernel. So this is an open source project that we've got at Microsoft. And if you spend any time kind of digging into the Python space, you might come across things like LangChain. Semantic Kernel is similar to LangChain. It tackles things from has some slightly different approaches to it, but it's also a bit more of a abstraction over your LLM. So you can use like Hugging Face if you don't want to use OpenAI. You can use a whole bunch of different vector databases, not just like CogSearch or Redis. You can use Pinecone and so on and so forth. But it can also help with mapping through decision trees and stuff like that. But we already did our secondary demo. So let's just wrap up there because I know that we've hit the top of the hour. And these are, I guess, the key takeaways that I want you to have from this. First off, when we talk about AI, like AI means so many things. It could be NLPs, it could be image classifications, but more importantly at the moment, people are talking about generative AIs. And that's the sort of thing that we're seeing with OpenAI. And that's kind of the next wave that's hitting us with the way that we use AIs. And the kinds of AI that we're talking about here is generative AI. OpenAI is an organization that we at Microsoft are partnering with to produce services for generative AI. We have a extension on top of their GPT models, Azure Open AI service, and you can work with that from a .NET standpoint through the azure.ai.openai NuGet package, which is essentially just a wrapper around some REST endpoints, or you can go directly to that. Obviously, things I didn't talk about either today was how you do image generation or speech to text, which is through like the DALL-E or Whisper. So DALL-E for image generation, Whisper for speech to text. I don't have some good demos of that pre-canned that I could have just fired off today. When you want to try and get into some more advanced stuff, it's worthwhile looking at an orchestrator. Something like Semantic Kernel in .NET. There is LangChain if you're wanting to go down that route. There is a .NET implementation of LangChain. It's not as fully fleshed out as the Python or the JavaScript versions, but there are things I like about semantic kernel, but there are things I also dislike about it. I said the complexity can be quite challenging. That's why I tend to start with just raw OpenAI. And for that sample application that I had, you'll find it at github.com/AaronPowell/console.gpt. And it's got the OpenAI example that I had in there. I did not commit the connection information to Azure OpenAI service, so you'll have to provision your own service for that, or you can use OpenAI directly, and you're either a paid or a free account there. There is also an implementation that uses semantic kernel if you want to have a look at how you bring an orchestrator into that. But yeah, with that, that's kind of enough of me talking for this evening, I think.
Thank you very much. We do have one question from Dimitri, and I mean, it's kind of a question. I don't know how do you want to address that? You said, so with all respect for this great demo, it's an API talking to a black box. Sorry, just trying the devil's advocate hat. Not quite sure what you're looking for, Dimitri, on that one. I mean, it's true.
Look, it is true, and so like I will be perfectly transparent. I am not an AI researcher or anything in that regard. I am very much a consumer of AI services. I don't understand how you train a model beyond I can upload images to like cognitive services and train a pre-trained like base image model. So I don't understand the fundamental pieces that make up an LLM and how you produce an LLM. And so what I found is that it really has been very much a exercise in discovery. Like as you saw in that final demo there, like I was putting things in, I'm like, oh, that didn't work the way that I thought it would work. And there's actually quite a lot of that has happened in the way that I'm doing AI. Actually, I will do one more demo.
So was an odd one. I don't know why it came up with
let's just show what happens if we change temperature. Temperature. Okay, so let's put a temperature of 0.3F. So this is changing the amount of creativity that we'll have when the AI is producing something. Tell me about Aaron Powell. All right, so let's run this. And if I could spell temperature correctly, that would probably help. Temp. Oh, wait, no, sorry, it doesn't go there. That's in the constructor, that's why. Temp. There we go. Okay, so we'll do that. Okay, so let's make it less creative. So the closer to 0 you get, the less creative. The closer to 2 you get, the more creative. Okay, so it has said, Aaron is a software developer and technology advocate known for his work in the field of web development and open source software. Oh, apparently I'm I mean, sure, I will put that on my LinkedIn in the morning. I am a CEO of some organization.
I hope they pay well.
Yeah. But so there's a level of creativity in there. Let's turn this down to 0. Make it not allowed to be creative in the slightest. So I mean, I haven't put anything in the system prompt around controlling anything beyond that. There's possibly an American philosopher out there named Aaron Powell. I don't know, but that's.
It sounds like he's higher in the result list. There you go.
Yeah. Okay. Cloud advocate at Microsoft. Okay, let's just do this. Let's go at 0.0 again, and we'll run that. And we'll see what it brings up this time. Okay. Okay, so this is like, I guess sounds a bit more like me, but it's also like you'll see the words in there are very mundane. It's very clearly simplistic in the way that it's described things. Where he focused on helping developers and organizations leverage cloud technologies, passionate about yada yada yada. That's very, very simplistic. Let's try the same one, but with a creativity. So now we're allowing it to be a lot more creative in the way that it's going to generate a response. Known for his expertise in cloud computing and web development. So here you see like the language is a bit more flamboyant and stuff like that. And then like you can really turn it up to well, 2. I was going to say to 11, but that's not really what it's doing. So let's just run that through. This one's actually probably going to take quite a long time because what I've said is like all guardrails are off. Just generate completions however you see fit based off of the preceding statement. So like what's in the message there, just go nuts with it. And as a result, it's going to take a lot longer to generate you a response because it doesn't have any kind of constraints. It can, I think previous times I've tested this, it can take like close to a minute just because it's, well, it doesn't have stop points per se. All right, well, yeah, it's getting close to a minute. So yeah, and just to one of the questions I see there while this runs out about you can't create your own OpenAI, but yes, there is plenty of other options out there. There are some open source ones and some free ones. Hugging Face is a good option, and some of them you don't even have to run as servers; you can run them locally. Okay, cool. So that has completed. Cloud Advocate at Microsoft playing an important role in the energetic technology tech company officially towards developers. Now you can see. So this is where you can see that it starts breaking down, and to the point before around like it's a black box. Like we don't know what it's going to generate, and here you can see it is really like it's just gone. Well, that's a word. That could be a word like control widespread. Like widespread is a word that could come after control, so I'm going to put it there. By advancing being people, like those are words that can be together. Maybe not necessarily, but yeah. So this is where you kind of got to experiment and just see what it does because we didn't give it any guidance or any restrictions. We just said generate. So that took a minute. I've done this before, and it can generate things that are just it's not even words.
There weren't even words too.
Yeah. There was a few. I did one before, and I think the output's on my blog. Like, what is the most recent Star Wars film? And like, it just generated things like they were series of characters that were not words, but they were characters that could possibly go next to each other. But then every now and then there were words that were like space and like stuff like that, like words that you associate with Star Wars. But it didn't make any sense whatsoever. All right. Anything else in chat, or like, am I just playing around here and seeing what we can generate from an LLM? Giving it a minute of runtime each time around by advancing being androids. That's yes. Cool.
And yeah, we might need to wrap it up soon. Let's see.
Yeah.
Last run.
Yep, there we go. There's a look. At least it got the start. And esteemed individual. I'm not reading any further. That we'll take that as a win.
All right. Well, thank you very much, Aaron, for this very interesting presentation, and also the last overheated responses from the GPT. So very good.
Yep.
Yeah, I'm sure everyone enjoyed the very professional presentation too, and the
Yeah.
meetings, the
Just
Teams, of course.
final plug. On my blog at aaron-powell.com, I have started running a series around intro to .NET and generative AI. So I've done 3 posts now, just looking at generalized concepts, the OpenAI SDK, and chat completions. The next one I'm going to do is around image generation. I just have to get some time to actually write that, because that's obviously something that people are definitely interested in, how you do image generation with AI systems. And then we'll break it down piece by piece. Okay, back to you, James.
It's all good. So thank you again, and I think we better give the prizes away. So I've got a couple of questions. So first one to give the right answer wins. So first question is, what's an embedding? Turning text into vectors. Yeah, that sounds pretty good to me too. Oops. All right. So Dimitri, send me a meetup message with your email address, and I can send you the license. And why not just an easy one for the last one? So what does LLM stand for? It's a license for JetBrains. You can choose any of the JetBrains products. There you go, Raymond. That was an easy one, and you win. All right. So just send me a message so I remember, or an email so I remember to send you the license. Sorry, just missed out. Genius. So next time, come back and you have a chance. You want to pass it on, Raymond? You're well licensed. All right. So yes, please send me a message through Meetup messages with your email address, and I'll send you the license. Raymond's kindly handed the license to you. All right. Well, thank you everyone for coming tonight. And again, yeah, it's hard to get real applause in this, so that's still pretty good. So if anyone's got any talks that they want to give, I think we've actually got pretty much people booked up till next year, which is not that far away. But if you've got something you want to talk about, please drop me a message, and we'll definitely talk about it and slot you in for some time early next year. So good night, everyone, and see you next month. Next month, I think we've got a security talk on AI-related things as well. So it's AI in AlterNet and everywhere.
It's all about AI.